So it's the change in speed, not the speed itself. And I think Adam also had a good thought on it being convex versus concave can tell you differently, which is what's going on here. But who can tell me where they think there's going to be crevasses in this image?
The front.
Yeah, as on the highest part of the rock, right?
The nose.
Well, in this
Where-
one.
oh,
We're not
sorry.
even to the rock yet.
Oh,
First one.
The front nose. Where
yeah.
it curves.
As it's creeping down, I would assume where the curve is greatest at the front.
At this part?
Yeah.
Okay, so in this particular one, you might see some there, like this. That's kind of what you're thinking, right?
Mm-hmm.
You probably would.
Maybe-
You actually would.
Maybe also along the edges of where there's more friction along the sides as it's going down, so maybe, yeah.
So this is right. This is what would sometimes look like a calving event, depending on your glacier. So where it gets too steep in the front, you're definitely going to have some there. Do you see anything else in this front area that looks like it could be stretching in any direction?
The sides.
The edges, kind of corner area.
Yeah.
With,
Up there?
yeah.
Okay.
And then like a little bit down as well. Right there.
That's what I was
Yeah.
thinking.
Do you want to point out where you think the crevasse is going to be?
Yeah.
And
Right. Here, you get like the mass pulling here and stuff here.
In what direction is the crevasse going to go?
wouldn't the areas along the side, like right here, also be crevasse?
Well, let's go one step at a time.
Okay,
we're
sorry.
still working on the terminus.
Okay.
So he says we have ones like this, maybe, and like this.
Yeah.
Okay, what else?
Oh, I was thinking, go up a little bit with your fingers, either, over to your left, left, yep, right there, where that dot's at, I'm thinking it's kinda, see how it starts to come down into a V? I'm thinking they're gonna kinda be a little bit like that, a little bit, like, just a little bit, yeah.
This way?
Yeah, a little bit.
Yeah, they might actually, because you've got this rollover that's happening there.
What about way up at the top?
We're still working on the terminus.
Oh, I didn't.
I didn't know that either. I didn't know.
There's a couple more that there's one
That was
more
the
big
thing.
one that I probably expect that might have a couple of witnesses with it.
What about the other horizontal ones?
Yeah.
This is, so there's these horizontal ones, there might be some more horizontal ones around here. Whoops. But there's actually going to be more this way, even right up to the tip. Because what this glacier is doing is it's coming down and it's starting to spread out this way. So you're going to have crevasses right where all of your fingers get. Because it's any kind of that stretching, spreading motion will generate the crevasses.
So you'll have the horizontal and vertical at the same place? pretty much?
You can.
Okay.
Mm-hmm. And okay, and then so Cucina, you brought up another one. What's happening on the sides?
Yeah, along the margins, it's like interfering with the glacial valley on the edges, so it's kind of sticky. It's sticking to them, but yet it's still flowing downward, and you can like see the little linear formations where I
yeah,
think
you can almost
crevasses.
see
Yeah.
some linearities there. So this is moving a lot faster than that, right?
Yeah.
Because we have the friction of the wall, and then it's thinner over there, right across. So in this case, we can see this little, that it's pulling it and stretching it that way, but this is going faster. What we'll end up with is basically ones that kind of look like this. all the way up, and I'm going to erase this guy. Because what's happening is you're pulling this way, and it's stuck over there, so you're going to open up a crevasse. And these are almost always at 45 degrees angles. And then, Stefan, you were saying something about up here?
Yeah, if it's stopped up there, then it's gonna pull it.
Right, if it's thinner and stopped up there the way all of us said, we probably would end up getting some up here.
Yep.
It's hard to see all of those details exactly. But then let's go down here, so well, let's just go all the way to the end. So which ones of those are we still gonna see on this end one?
All
All of them?
Okay, so we've got these guys up here, and we have these guys here, and we might have some of these guys up here. But what happens over the rock now?
So that's the base of the rock. Like when it comes down over, you can kind of see the indentation.
Down here?
Yeah. Yes.
Yeah, they
Yeah,
would-
like it would be almost like a smiley face. I think it'd be a big crevasse going almost horizontally. Something like that. Yeah, a little bit like that.
So remember when we bend the Snickers bar this way, we open up. When we bend the Snickers bar back that way, we close them back up.
So they'd be up
Here, we're actually bending the Snickers bar the other way. But up here, a little bit, we are bending it over the rock. So yeah, you're right that there'll be some here. But they will stop somewhere in there. There'll be a transition between the concave, the convex to the concave version.
You also have them on the uphill side when they start going. The slope starts flattening off.
Yeah, so you always get them a little bit on this uphill side of the rock. It's hard to tell from this where that would start. Where it starts getting deformed by the rock, you'll see a few of them, yes. And then
We have the long wise too on the sides of the rock.
yeah, so as it comes up and over this rock, it's spreading out laterally, right? It's oozing out the sides. So we're actually going to get some stretching that way as well. So there probably will be some that look kind of like this. And then these sideways ones, they're called en echelon. Does anyone here speak French?
I took French, but I don't remember that word.
Basically means lined up like soldiers, in line. Because there's always this very regular pattern, choo 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 choo, all the way up. And they're so predictable that once you find, as long as the geometry doesn't really be crazy, it's pretty easy to figure out how to navigate in between these side ones. The central ones can be a lot more puzzling. But these en echelon ones, that's why they're called that, because they're very organized and like a soldier's marching kind of
Does
in line.
echelon mean soldier? Something along those lines.
I don't think that means in soldier, but I think it means
I think it literally translates to inline.
in
Oh,
line.
cool.
Yeah,
Okay.
I think it's.
Yeah.
So the main point here, you can almost look at any glacier, and if you see those patterns, you can get a feel for how it's moving just from looking at the patterns. You can also decide where you want to pitch your tent, which I might, it depends on how close here. I might choose there or up there somewhere, depending on the topography, because you always want to pitch your tent where you think there's going to be the fewest crevasses. But the point is that it's not the velocity itself that determines where the crevasses are. It's how the velocity is changing spatially. So here it's faster inside than it is outside on the edge, so we've got crevasses there. Here it's spreading this way, so even though it's all moving downwards, it's more the spreading that matters. And then here you've got the very tip is moving faster than just behind the tip. Same thing up there, wherever it's spreading. So that strain experiment that one group did was really, I thought that was really cool to show that kind of stretching you can get. Okay, so that's about the glacier crevasses. And there's two more things that we wanted to get to. This is the problem with the oral presentation class with 12 of you, because the presentations always take longer than I think they want. I did, based on, what just happened there? Wow. In this assignment that I gave you, I just wanted to, is somebody knocking? I did, Amanda just pointed out that there's this plot in here with the little stars on it. It doesn't actually have any labels on it, which is my fault. Actually, I took this from another professor, so it's his fault. I'll blame it on him. So I did just want to, this is, just explain this a little bit more. Distance down glacier. And then 0.5, 1, and 1.5. It does say in the little box that it's the ice equivalent of remaining snowpack. But what this really is at the end of the year, this is the, I can write this, the accumulation, the net accumulation for that year at that point. So at the very top of the glacier, up high in the mountains, it received 1.5 meters of water equivalent snowfall. Halfway down, 500 meters, it received about 1 meter of snowfall. So this is because we snowed all winter and then we started to melt it in the summertime. And then down 1,000 meters downstream, it still had 0.5 meters of snow left at the end of the season. And you could extend this plot, but that's what this is showing. So at each point on the glacier, and isn't it Harry that was making these measurements in this one? He's walking down and measuring his stakes. The higher elevation ones, or the ones at the very top of the glacier, had the most snowfall at the end, and then this is down where the hut was at 1,000 meters. Does that make sense? Okay. So, the last thing I wanted to touch on today was, I'm going to give you guys a few minutes to meet in your groups, unfortunately, is to talk about turning your flubber experiment into a teaching lesson. On that piece of paper. There we go. Oh, come on. Here it is. Does anyone here have any experience teaching?
I took a teaching class.
You took a teaching class? What did you
I do tutoring, but not the kids.
do? Tutoring?
Yeah.
Amanda?
I tutor.
You tutor? And Raph, did you?
I've do a little TA,
Mhm.
but and when I worked for Halliburton, I actually taught people how to do the experiments. So
Yeah, so there's a lot of, like, all kinds of teaching has a lot of similarities, and it's actually not that different than the presentations you guys give. Because the first thing you need to know is, what do you actually want them to walk away knowing? In the learning, in the teaching world, we talk about that as, what are the learning objectives? And so you really need to know what you want your students to walk away understanding. And the more specific you can be, just like with a presentation, the more specific you can be, the easier it is for you to design your teaching activity to get at those questions. But then what I find can be really effective, I use this a lot, there's these 5 E's on the front page of this. This is just one way of describing what's called the learning cycle. And I find the 5 E's is just a nice way to synthesize it and be able to think through it for yourself, especially when you're first trying to figure out how to do that. And the first one is to engage or invite the learner. That's the same as like the hook for a presentation. It's the same as like getting them on board with what you're doing. And there's a lot of different ways you can do that in teaching, but that's pretty important, because if you don't have your students on board, they're going to be off wandering mentally and thinking about other things. This is considered a pretty effective way of teaching a lot of different things, and you'll see some tendencies in the way that I teach. So rather than just give straight up lectures, which doesn't really, that's very teacher-centered teaching rather than student-centered learning. Giving the students a chance to explore and experience, so doing something that's hands-on and giving them the chance to explore it. So you've engaged them, and then you give them a chance to explore it and experience it for themselves. And then after they've had a chance to experience it a little bit, then you go through helping the students figure out how to explain what their observations are. So the explain is not necessarily you just explaining to them. The explain is them being able to explain it to themselves or being able to explain it to their peers. The next step on that, which you don't always get to right away in just one teaching lesson, usually you kind of finish it up this way, but is to elaborate on that, to expand it or to extend it. So take the lesson, what you just taught them, and ask them how it applies in a new place or a new time. Get them to think about it beyond that classroom you did, and that helps them solidify it in different ways. And then the final one is to evaluate, and that again is something that you won't necessarily get to in this assignment, because that's more like that's figuring out, well, how do you know that they've learned what you wanted them to learn? It's also kind of, there's 2 different types of learning feedback for in terms of evaluating whether or not your students are learning. One is what we call formative assessment, and that's that, like, every minute of the teaching time you're making observations and being like, oh, that student isn't getting it, why not? What do I need to change in the moment to help that student get it? So you as the teacher are constantly sort of feeding back on what the students are giving you and modifying your ideas right there to teach it. The other kind is called summative assessment, and that's tests at the end, where you've gone through the whole thing and then you give them some kind of an evaluation or assessment at the end to figure out if they learned what they were supposed to learn. And I'm not expecting you to do the evaluation part, that end evaluation at the end of this. But you should be aware of that process of thinking about how to, what kinds of things that you might need to be aware of and responding to in your students' minute-to-minute actions. So you really just as a group need to kind of fill this out. There's 5 questions there. But then you need to, so if you work through these 5 questions and then pull that together as a, what are you going to do on a step-by-step basis in this? So there's the 5 questions are, what do you want to teach? So what is the message? How are you going to engage the learner? So getting that first engagement in there. Finding out what the students already know. So this is kind of an important step that's usually done as part of that engagement. It's like, well, I want to get you excited about it, but I need to draw you in, and one way to do that is to find out who's done something in the past. Like I just asked, who all's taught before? So at least that gets you, and I could have gone further with talk to you about, well, what kind of teaching and how have you approached stuff, just to get you engaged in thinking about your past experience and how it relates to this current one. So number 4 is, what will the students actually do? How do you envision the flow of events that will give them that time to explore and experience? So you've got the flubber. Some aspects of what you guys did were probably too complicated for a 4th grade class, but how would you simplify things to really get effectively across a point using the same idea? Like maybe you would simplify it down to just doing the same thing with a slope, but not, like one team, you guys did that, but you put together the complicated stripes, and like how could you simplify that experiment down to something that you feel like would really get a key point across to those 4th graders. And then part 5 is, what will you do as a facilitator to help the learners come to an understanding? So this is where you have to kind of envision the step-by-step process that the students are going to go through. And then think about, well, what are some questions you can ask them while they're in the process of doing this? What do you need to watch out for in terms of their interactions with the other students in the class? Or what kinds of things do you think you might need to be aware of as you're working with them? Pages 3 and 4 in here really summarize some of the key characteristics of your lessons, of any lesson. So
is this guidelines then? Something we can look at?
these are guidelines to look at. And if you go down here and you're like, after you design your thing, encourages questions from learners. Well, we didn't really design ours. We just told them what to do. We didn't really encourage them to ask questions. Maybe we need to rethink how we do this. So if you go through this afterwards and you're like, we do fit that, or we don't, this is a pretty extensive list. So you might not capture every single one of these, but hopefully you capture a lot of them. Like accurate, present science content accurately. That's one that hopefully we'll all catch. And yeah, is it at the right level for the students? Is it developmentally appropriate?
What age group, did I ask you? Who we-
4th grade.
So we're actually doing it.
No, because my friend who has the 4th grade class isn't able to do it this year, unfortunately. So we will, it's hard, sometimes it's hard to, how many people here know somebody in the 3rd or 4th or 5th grade, or have recently talked to? What are some characteristics of that age level?
Pretty stubborn.
They can be very
And
stubborn.
they're energetic too, though.
They're I know a boy, and he needs just so much energy. It's all over the place. He just wants to be outside.
Yeah, they
It's
have a
hard to
lot
get
of
him to
energy.
hold
And what was
still.
that? What was that game show? Are you smarter than a fifth grader
Yeah.
or something? So that fourth or fifth grader is actually when they love asking questions. That's
Yeah.
when the why comes out. So it's actually a really fun age to teach because they're starting to get stuff and they're starting to be able to process information and pull it together and ask questions. So thinking about it as fourth graders doesn't mean you have to take the level down super low.
Right, yeah.
Actually, you'd be surprised at how much fourth graders can handle, and probably will surprise you with big questions. And if I can try, I might get a fourth grader to come by. I have one or two friends with a third or fourth grader that I might be able to talk them into coming by and being a little bit of a feedback. Anyway, we need to finish up here. But the point, what you need to do for this assignment, it's only going to be half of this. You see the assessment says your plan is 40 points and then the rest is 40 points. But first I would answer these 5 questions, and that will set you up to actually writing the plan. So you have to do more than just these 5 questions, but these 5 questions are the first thing to do to get to the plan.
So we're doing this as a group, right?
Yeah, but what I would do is do the first,
So can we just have like one
Actually, yeah,
sheet
you can-
for the whole group?
yeah, you can have, so you can do all of these 5 questions as a group. And then the plan of like, we're gonna have this much flubber available and we're gonna do a slope, what is the exact experiment you're gonna do and how you're gonna step through it. And you can visualize yourself walking into the classroom. What do you need? What's the first thing you're going to do? What kind of an introduction or engagement are you going to do? Sort of that step-by-step part of it. And to step-by-step, you can use this. What are we going to do to engage the learner? Blah. How are we going to explore an experiment? What's the specific steps you're going to follow? How will you then turn that into helping the students explain? But answering these first 5 questions will set you up to being able to write out the full plan.
This is our same groups we just worked with.
Yeah, the flubber groups, because you guys all had concepts together you were working on.
So is that what we're supposed to base this on, the flubber?
Yeah.
Okay.
Yeah. Basically just redesign an experiment, simplify it from what you did last week, and write it up so that you could teach a specific
I'm
concept.
So it
sorry.
has to be about glacial flow or some other glacial aspect.
Do we wanna?
Whatever you can do them with the flubber.
And you probably said this, but just to make sure we
Oh, I
are
have to
presenting it out loud to the class.
Will you come before?
Or
We'll
kind of
discuss it as a
okay.
group. It's
Sounds
not
good.
really going to be a
Okay.
I have
presentation.
Okay.
1
Just
hour
talk
free.
about what we would do
Presentations,
if we
yeah.
were
Are we
to.
able to do
Sounds
this?
good.
1 hour free, 1 hour free time before the class.
On Thursday?
Yeah, we can stick to that
And then we
schedule.
could work on this.
We gotta go to this. Yeah.
Do you have a
It's
week
okay.
for it?
Yeah.
Have fun.
So when would you like to get together?
We'll see each other Thursdays.